Just go ahead and say, what form is this? That's standard form. So just thinking back to the quiz, that all that stuff, or most of it, will be on your final test for this unit, like I was saying a bit ago. Like there's a lot of information that can go on your note card that would be helpful, like the procedure for finding the vertex in standard form. And so I might organize my note card, like here's my little note card, and I would do standard, and I would do vertex, and I would do factored, and then just put everything about each form on there, or some version of that, right? There's really no reason to miss some of this when you have a note card with it right in front of you. And that's not an Algebra 2 thing, right? That's just an employability skill. Like, can you follow directions kind of idea, right? Can you read a manual and carry out your duty based on the manual? So don't think of it as, can I do Algebra 2? Think of it as, can I function in a work kind of environment? Because if you're allowed to have the directions or the, like I said, like the manual, the note card, it's just kind of plug and chug at that point, right? Here's what I mean. On your note card, it should say negative b over 2a for your vertex, for your x coordinate. So label it x coordinate of your vertex. What is b? Well, it's negative 10. So this is really negative 10, and then a is 1. And so the x coordinate is 5. We can go put that in our vertex right now. Okay, and then we go to get the y coordinate. We just plug that 5 in, and it's 5 squared minus 10 times 5 plus 9. So again, this is calculator now. So plug it in, do it in your head, but check it maybe on a calculator. So 25 minus 50, that's negative 25. And then going back up from negative 25 to negative 16. So our vertex is at 5, negative 16. And just graphing this. So I'm going to go by 2. So 2, 4, 6, 8, 10, 12, 14, 16. So I'm going to put my vertex right there and go by 2s on the y-axis only. Okay. Does this open up or down? Opens up. Is it stretched or compressed at all? No. So it's just the normal graph pattern. So over 1 squared is 1. So it goes up 1. And then over 2 squared is 4. So over 2 up 4. And I think that's sufficient right there. Now, actually, I'm going to revise that because we can find the x-intercepts, and that will be sufficient at that point. So I'm going to do that next. I guess before that, let's do the the axis of symmetry. Some of you lost points, or at least half a point it was, because you didn't write what on the axis of symmetry? X equals. And so this is a vertical line. Vertical lines are x equals some number. Again, that could go on your note card, right? Vertical line, x equals, or always write x equals. I'm pretty sure we wrote that in the notes. What x coordinate does this go through? 5, yeah. Okay. So on your graph, this is not necessary, but you could go put your axis of symmetry right through the middle if you want. All right, let's do those x-intercepts. What's the best way? At least to start out, what's the best way to find them? We're going to learn 2 more ways, but what's the best one to try first? Yeah, factoring. So we'll star this. I do want to write it first as set equal to 0, because remember, that's what it means to find x-intercepts, is find the zeros, to find where it equals 0. So what is a times c? Let's do a quick review. A times c is what? 9. B, negative 10, and then a goes over here, and it is 1. Are there factors of 9 that add up to negative 10? What was it? -1 and -9. Right? Those multiply to make 9 and add up to -10. Then we need to reduce these sides, but in this case they already are reduced. So we'll get x minus 1 times x minus 9, and that's still equal to 0. Pause there on your, anytime you're doing this, pause there and check that you factored correctly. So x times x, that's x squared, that looks good. Then we get -9x, -1x, that makes -10x, and then +9. So yes, we're factored. That took about 6 seconds to check, right? It's worth it. I told you I even do that. All right, now we set each of these equal to 0 to find where each piece is equal to 0. I don't need those parentheses. Okay, so we have 1 and 9. There's our two x-intercepts. Do I write it? So back up here to the question, fill in the blank. Do I write it like this, 1, 9? No, because that looks like a point, right? So you can say x-intercepts 1 and 9. You could put a comma, but just don't put parentheses, okay? Because that makes it look like a point. I'm assuming this is 10. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. All right, so my two x-intercepts kind of complete the picture for this graph now. Something like that. All right, y-intercept. How do you get that from standard form? Just C, good job. So the y-intercept is 9. Technically 0, 9. And clearly now that we have it graphed, it has a minimum. But how would we know that if it hadn't been graphed? That should be something you can look and just get pretty quickly off the thing. Yeah, Troy? Yeah, if A is positive, like this one, it has a minimum. If A is negative and it's flipped over, then it has a max. Okay, what is the y value? That's what we're asking for on value. -16. Okay, domain for this. Yep, infinite, negative infinity to infinity. Range. Good. -16 has a bracket because it does go through. He was looking at the bug. And to infinity. Guys, on the quiz, you also had positive, negative. So positive, remember, is above the x-axis. So what would that, I didn't put it on here, but what would that look like? Where is it positive? Above the x-axis. Here and here, do we agree? But those are both arrows, so they're pointing to infinity in each direction. So maybe I will write this. So interval of positive is what? -infinity to 1. And then our union symbol, and then what? So that was this piece going off this way. And then 9 to positive infinity, that's this piece going off that way. Okay, where is it negative? Yeah, negative is down here. I'm not intending to make it look like a bird face or something, but do we do parentheses or brackets on this? Parentheses, just because we're not worried about, like, let's close one interval and open another, and it can't be both at the same point, that kind of stuff. All right, as a quiz type problem, rate yourself on that one, fist of 5. Okay, that's pretty good overall. I would say we're averaging high 4s. Cool. All right, what form is this one in now? Factored form. So it says find the vertex, but in order to do that, we need to do something else first, which is what? We actually don't need to convert it to standard first. I mean, you can, and since it says to do that, I guess you could, but that's a lot of extra work. So again, on your note card, write down what the intercepts are. What are they in this case? That's the whole goal of factored form, is it immediately tells you those x-intercepts. 6 and negative 2. Okay, so think about it. Just sketching this. There's our two x-intercepts. And does this one open up or down? It opens up, and I'm not worried about it being stretched or compressed, but for this, anyway. So do you agree that our vertex has to be right smack in the middle of those two? Because parabolas are symmetric. So for the vertex, can't we just average those two? Remember that? 6 plus negative 2, and then average means divide by how many there are. So 6 plus negative 2 is 4, and so our vertex is at 2. Well, the x-coordinate is at 2. And look, even on my sketch, I happened to nail it right on. Powerful, right? Like, sketch this stuff. That was a literally 3 or 4 second sketch, and it happened to go right through 2. Now, you're not always going to hit it like that, but that was good enough to verify. Do you agree? All right, so vertex x coordinate is going to be 2. How do we get the y coordinate? Yeah, now we know that the x coordinate is 2. So just stick that, Stick that 2 in there. Be careful with this. It seems like people mess this up. If you have a good calculator, you can punch it in exactly like that and just hit enter, and it will tell you. But let's think through it. 2 minus 6 is what? And then obviously 2 plus 2 is positive 4. This is all multiplied. So we get negative 12 for the first two times positive 4, which is negative 48. Okay? So this one on a graph would be kind of way down there. Cool. All right, standard form. Let's do that in the middle. You have a couple ways that are okay to do this one. Or not this one, but this process, I mean. Let me talk about the one you don't want to do. Do not do this. Why? Okay. Well, let me give you an example of why not. If I said, what is 3 times 2 times 4? What is that, first of all? It's 24, right? But if you do what the arrows are showing up there, you would be doing this. Is that the same thing? Because that would be like 3 times 2 times 3 times 4, right? Which is doubling how many times you use the 3. It's squaring it, really. So it's not accurate to distribute all of that. Okay, so what is okay to do if that's not okay? You could do it on one of them. That's totally fine. Okay, just picture the 3 being with only one. So you could multiply out 3 and negative 18 times x plus 2. That's a pretty good way to do it. Or the other option is leave your 3 alone for now and just work on the 2 parentheses, like inside of brackets or something, and then distribute the 3 at the end. So which do you think is easier for you? Okay, and it's going to be different for everybody. But let's just kind of show. So this one will, now it's okay to distribute. So we'll get 3x squared, and then we'll get 6x minus 18x minus 36. So 3x squared, and then minus 12x minus 36. Okay, this one, leave the 3 out front. You'll get x squared plus 2x minus 6x minus 12. Go ahead and combine those like terms still before we use the 3. So x squared minus 4x minus 12. And then distribute the 3 to get the same thing that we just got. So again, it's kind of up to you which one you think is easier. I kind of feel like that time the first one was, but either way. Just don't double distribute your 3. How'd that one go? Fist to 5 if this was a test question or some version of that? All right. Looking pretty good overall, I think. So we'll keep reviewing this. Like I said, probably not going to get to this quiz or this test next week, since we only have class on Thursday. I guess there's a chance we could. So be studying. And I don't think we might. I'll just leave it open as we might. All right, in terms of homework, it was about 12 of you, I think, that did that. So let's check it and just make sure you did it right. So it's 20 to 29 on 2.4. So I'll read these to you. Number 20 was 11. 21 was 9 minus 6i. 22, 1/12 minus 7/12 I. It's fine to leave it as a fraction. In fact, probably preferable to do that. 23, negative 2 plus 8i. 24, negative 33. 25 is 12 plus 15i. 26 is 29. 27, 55 plus 48i. 28, negative 2 plus I. 29 is 53. So any of those that you would like to do, or like me to do, I mean? Yeah. 28, okay. All right, we're doing 28. So this is multiplying. And I would do it this way. What is 1/3 of 3? 1. So that first one is 1, and then we have our I tagging along. And then second term, what is 1/3 of 6? 2, so 2, but then we have I squared on that one. And what is I squared again? Yeah, I squared equals -1. So this is 1i plus 2 times -1, which is -2. And now it has to come out front to be in, I'll just leave the 1. To be in a plus bi form, that 2 has to come out front. Okay, what else? Any others?
Number
29, okay. I'm going to get rid of this for a second. Okay, this one is where we're distributing all this stuff. So negative 2i times 7 is negative 14, negative 14i. Negative 2i times 2i, not plus, is minus 4i squared. And then 7 times 7 is 49. And then we have 14i at the end. Can you see that? Is that okay? It's because it goes off the screen otherwise. Okay, now we start combining our like terms. You can do that first, or you can say, hey, I have an I squared, and deal with that. Which do you guys do? Like terms first, okay. So I see an I and another I, and it's the same sign, or excuse me, the same term, different sign. So those actually are 0. Now we have negative 4I squared plus 49. What is I squared? Yep. Okay, so that's actually 4 now. So that becomes 4 plus 49, or 53. Did that help? Okay. Any others? Okay. 25. All right, multiply. So we'll get 15I. And then 3 times negative 4, so minus 12, and then I squared. Remember, I squared is negative 1. Negative 1 times negative 12 is 12. That is now the front term because A has to be the real part. So this becomes 12 plus 15I. You will need to be able to multiply in order to do the rest of our class today on simplifying quotients. And it turns out it's like this. We saw one like this yesterday. Does anybody remember the name of these two kinds? Even though they're kind of in a weird order, it's the same thing as what we said yesterday.
Complex conjugate?
Yeah, good job. Those are complex conjugates. And the cool thing about those, do you see how the I term went to 0? Right? That's the goal. We want to get rid of that I. So complex conjugate. How did adding and subtracting? Are we doing okay on it? Okay. Cool. Let's go ahead and grab your notes and let's do an example on division or quotients. Do you guys remember what quotient means? What does it mean? Yeah, it's from a division, but we can also see it as a fraction, it looks like. That's kind of the idea. But we're not going to actually divide. That's why it says simplify. Okay. It's okay. All right. Everybody got what you need. So we're going to go 10 minus 3i over 2 plus 7i. How many complex numbers is that? That's 2, right? One on top of another, that's just 2. So we would like to get rid of an I and like not have this ugly complex fraction like this. So you're going to multiply both top and bottom. By the complex conjugate. And we'll write what that means. Of the bottom. And the reason why we're doing the bottom is because then we can write this in a plus bi form with something underneath. It'll have a little fraction, but it still will be a plus bi form. So the complex conjugate is just the same complex number with the middle operation switched. So we'll just do a couple quick examples on the side here. Something like 3 plus 2i becomes what? 3 minus 2i. So you would multiply by the same thing, only switch the plus to a minus. If it started maybe as negative 5 minus 3i, what would it be? Switch the minus to a plus. Okay? So the complex conjugate, all you do is just change that operation in the middle. Switched. Okay. So what are we going to use for our example problem? We'll multiply by 2 minus 7i. So now this becomes kind of a multiplication and simplifying problem. Sometimes it helps to put parentheses around if that helps you see it. So I'll make note of that. Use parentheses to help if needed. Something like that. Again, it just kind of clusters things so that you can see what is multiplied. But you don't have to do that. Okay, what we should see is the denominator should clean up drastically. In the numerator, we don't care. Like, it can be messy if we want, or if it needs to be. So let's go multiply everything out. So denominator, do all this multiplication stuff, right? Our new fraction will look like 4, so 2 times 2, and then minus 14i plus 14i minus 49i squared. Any questions on where that came from? Numerator looks like this, 20 minus 70i minus 6i plus 21i squared. If you had to stop right there, it looks kind of bleak. It's sort of messy and ugly looking, but it gets better. So let's simplify, keep going. What happens to the 14 i's in the denominator? That should always happen. If it doesn't, you did something wrong. Okay? And then we have 4 and minus 49. And what is I squared? So times negative 1. In the numerator, we have our 20 minus 76i. Those i's will not, in most cases, will not cancel out. Okay, and then same thing, plus 21 times negative 1. All right, probably just one more line of simplifying. And it will look like what? What is the numerator? Actually, we've been doing denominator first. What does it become? 4 plus 49, right? So 53. I must have kept that in mind from that problem before. So this becomes 53. You want the denominator to be just a number like this. So make a note out to the side that says this. The denominator should always become a single real number. So if it doesn't, something is wrong in the process. How about the numerator? What do we get there? Yep. So 20 minus 21, there's our like terms. So negative 1 minus 76i. Now, technically that works. That is sort of in a plus bi form. But we could split the two pieces, the two components up if we want. And let me show you what that looks like. Right in a plus bi form. In this case, it would look like this. Negative 1 over 53 minus 76 over 53i. And of course, if we had an example where those two fractions could be reduced at all, then you would want to do that. So I'll just make a final note about that. Reduce the fractions if possible. I think you'll get faster at this. It takes a little while to explain through the process, but it's not too bad when you're just running through it. I just want to point out, though, once you've decided on your complex conjugate, this really becomes kind of like two multiplication problems, doesn't it? It's like multiplying the top, multiplying the bottom. It's simplify the top, simplify the bottom. It's not really till the end that you even combine them at all. So just stay organized, keep it neat, make sure that your fraction bar doesn't get lost, that kind of stuff. Any questions on it? Okay. Do you think it looks simpler in the a plus bi form? This one doesn't necessarily, but some of them clean up really well. Like they look completely better. So let me have you try one. Okay, a couple minutes to work through that. What?
I had it in my notes. Maybe goes, watch this.
In the comments?
Okay, good.
That's really funny. All right, what's our complex conjugate on this one? So negative 6 plus I, minus I, excuse me. Okay, there's your numerator. Guys, with all these negatives floating around, it is easy to mess the sign up, so just be careful. Remember that on the denominator, these two should always be opposite sign and therefore cancel. And then this last term will always be negative. Meaning maybe not the whole value, but the sign in front of I squared term will always be negative because we're always going to multiply in a way that those two have opposite signs. So they're always going to be negative. So it will always say on the denominator minus whatever I squared. All right, anyway, in terms of like terms in the numerator, we get negative 30 plus 13I, and then plus 3 times negative 1. Denominator, we just get 36 minus negative 1. And so our numerator becomes, at that point, negative 33 plus 13I, and 37. And then we could, if we wanted, write it this way. Did I check yours right? I'm like, wait a minute, I missed something. Okay, I'm gonna come look at it again. How'd you do on that? All right, try this one. Your complex conjugate is just 5i on this one. Everybody listen. You could think of this as 0 minus 5i, so then it would be 0 plus 5i. This becomes 50 plus 50i. Hold on. Homework on that sheet. 30 to 33 and then 46. 30 to 33 and 46. Anyway, this simplifies down to 2 plus 2i, if you got there. I'll post the rest of it. Actually, that is the rest of it right there. Yeah.
Are you still ready?